Good afternoon, everyone, and thank you very much for coming. It's a pleasure to talk with you today. So, as she said, I'm the program manager for CVN 78. I've been in that position for 5 years now. And so what I'd like to do is talk to you about aircraft carriers and specifically what we're doing on CVN 78. So first of all, I represent PEO carriers, and our portfolio consists of multiple product lines. In addition to new construction, which most of my remarks today will be about, we also take care, maintain the Nimitz class aircraft carriers. We do all the refueling complex overhauls for the Nimitz class aircraft carriers. And of course, in activation, right now the former Enterprise is currently being inactivated. So our portfolio covers all portions of supporting aircraft carriers from new construction through in-service and then ultimately disposal. So aircraft carriers obviously have been around a long time, and they've evolved tremendously over that time. You know, there's a lot of discussion about the evolution of aircraft carriers and the technology that they bring to the fleet. And what I hope to show you today is the next leap ahead that Gerald R. Ford and the Ford class is going to bring to the Navy. If you look at, say, the Midway in the center of that slide, the Midway was commissioned in 1945, and there were pilots flying off the Midway in Hellcat fighters. When that ship was decommissioned in 1992, she was flying Hornets. No one in 1945 had any concept what jet fighter aircraft, fighter attack aircraft were going to be in 1992, and yet the Midway had an incredibly successful career and performed beautifully all the way to the very end of her service life. And so we envision the same thing with the Gerald R. Ford. You'll see in my remarks that we put a lot of work into getting the service life of this ship right. There's lots of margin in this ship for future modernization, all the different things that we may not even be able to envision today that will be fielded 50 years from now. And we fully expect this ship is going to be capable of fielding that technology. And I'll talk to you a little bit about why we think that is. So just to finish up, the Nimitz class right now, the current workhorse of the fleet, it's about halfway through its total service life. The 10 carriers of the Nimitz class will represent about 500 carrier years of service. From the Nimitz, of course, that was the first ship of the class, all the way through the last ship of the class, the George H.W. Bush CVN 77. And so that class has got another 250 plus carrier years of life. She's going to be with us a long time, and we maintain committed to that ship, and as they phase out, the Ford class ships will phase in right behind them. So first of all, where are we with the Ford? The Ford is sitting right now at Newport News Shipbuilding, about 98% complete. So the Ford brings a lot of new capability, as I alluded to. So first of all, nearly 3 times the electrical generation capability that's resident in the Nimitz class, which is really important for the variety of, say, directed energy weapons that may be out there. Almost anything that we're going to put on a ship today requires electricity. We don't have any more steam on the ship except inside the propulsion plant for the steam turbines. All the steam that's routed throughout the ship on a Nimitz class carrier to power the steam catapults or to make hot water for a shower, all of that is gone on this ship. It's all electrical now. And even with that, we have lots and lots of margin in our electrical power for future growth. We also brought back all the weight and stability margins. So it's almost inevitable in shipbuilding, when you add things, you add weight. We always try to take weight off, but ships tend to grow in weight over time. And so what we've done with the Ford class is made sure we've reclaimed a lot of that margin, both for weight and stability. So no matter what we bring, the ship is going to be able to take care of it. But the centerpiece of the ship is the increased capability that she brings. The Ford is definitely going to support a higher sortie generation rate. We've done lots of design changes to the Ford, to the flight deck, to the systems on the flight deck. The island is further aft in the Nimitz class, and it's repositioned to maximize the movement of aircraft on the flight deck. We've added square footage to the flight deck in a few key areas. And then we've rearranged all the services on the flight deck, from the fueling services, the electrical servicing, even where the weapons come up out of the flight deck to service the planes, all optimized So the ship is designed from the ground up for today's missions and a fast turnaround of aircraft. And we're very confident that we're going to see increases in efficiency of aircraft on the flight deck. And we've tried to do this with affordability in mind. So we've designed the ship to take a lot of maintenance out. I mentioned steam earlier. Steam is a maintenance-intensive kind of system. Steam valves are known for leaking, corroding. It takes a lot of sailor hours to take care of steam valves, and as I mentioned, we don't have any of those. That's one example. There's numerous features we've put on the ship to pull maintenance out of the ship. We estimate that the maintenance workload on the ship will be 20% less than we currently have on the Nimitz class. Now the ship's designed to go 43 months in between maintenance availabilities and 12 years between dry docking. So right now, Nimitz class ship would dry dock twice before its refueling overhaul, then twice again before an activation. Whereas the Ford class will only have one dry docking between commissioning and refueling, and then one again between refueling and decommissioning. That saves a lot of money and increases the operational availability of the ship to the fleet. So today, the Nimitz class operates on a 36-month interval between maintenance availabilities. And it is difficult to integrate a single carrier into a fleet where everybody's on 36 months and then you got one ship on 43 months. So initially, the Ford class is going to operate on 36 until we get a couple more in the fleet and then can change the larger maintenance workload. You can't really have a one-off and have it fit inside the maintenance scheduling. But we are capturing the 12-year dry dockings right away. So the takeaway here is a lot of flexibility for future growth, increased capability, and an affordable, reduced maintenance ship with less sailors on board. So today, as I said, we're 98% complete. So almost all the construction is finished. All the production guys with welding torches and that's all gone, right? The 2% that is left is the final bits of the test program. And of course, when you're testing, you find the little things you have to fix and you go fix it. That's all that's left. There's 2,608 compartments on this ship. We've turned over most of them to the crew. So the crew is reported on board. There's over 2,000 sailors in a Gerald R. Ford pre-commissioning unit. They're there. They're taking ownership of the systems. They moved on board the ship in August. So they now live on board, they work on board, they eat on board, and they're taking control of all the compartments. And one by one, they're taking over all the systems as we finish it. So you can see from that slide, 74% of the systems on the ship are finished and turned over to the crew. I've still got some testing left to do, all mechanical, electrical testing, electronics testing, but those things are on track to finish up this summer. So a little update on some of the new technologies. The ship has the dual band radar. The dual band radar has two pieces, the dual band the multifunction radar and the volume search radar. So in that test program right now, the multifunction radar has done high power radiation from all three of its faces. We have tracked targets of opportunity, just regular aircraft flying around, and demonstrated that we can hand off the track between all the different array faces. Very successful testing. VSR just achieved high power on the third of three of its array faces just this weekend. So it's coming along just as well. Now the dual band radar integrates into a larger combat system, and that larger combat system testing, the soup to nuts testing of that combat system will be this summer. Following that, we'll go to sea and then deliver the ship. EMALS, a lot of people have talked about EMALS. I have a separate slide on EMALS coming. But to date, this slide I think says 235. It may not have the number, but we're now up to 242 dead loads. We launched the very last one last evening. And so those dead load launches that we did yesterday were done on ship's power. And so we have demonstrated the full powertrain from the ship's electrical generation all the way through to launching the dead loads off the ship. So a dead load is basically a weighted sled. I have a picture of it that weighs the same as an aircraft, and it replicates shooting an aircraft off the catapult. So we've done over 240 of those now on the ship, and very confident in that system. Advanced arresting gear is also in testing right now on the ship, a little bit behind EMALS, but coming along. And we expect both of those systems to be ready to support flight operations during the shakedown period of the ship. And I think that covers this slide. So I mentioned that the ship is almost done. So here's some photos of the inside of the ship. So on your upper left, you'll see that's Susan Ford Bales. That's Gerald R. Ford's daughter. She came on board the day that the crew moved on board, and she helped serve their first meal out of the galley. So the galley is completely operational and in use right now. They're serving 3 meals a day. The ship store is in use. In fact, if you go on board, you can go down to the ship store and buy some Ford souvenirs. The weight rooms are there. So, you know, when the Nimitz class was designed, the Navy culture of fitness wasn't quite what it was now, back in the 70s. And so she wasn't designed with gyms. This ship is designed with several gyms, designed from the ground up with fitness in mind, all fully outfitted, and the crew's using them. The damage control repair lockers, all the DC gear has been loaded on board the ship, and the crew's doing training with that gear and getting ready to take the ship out to sea. So one thing I'd like to focus on for a minute is if you look at that picture of the mess decks, you'll see the tables are they're firmly attached to the deck. That's something that you don't see in the Nimitz class. In the Nimitz class, the tables are portable. And the reason is, on the Nimitz class, when you bring weapons up from the magazines, you have to do some assembly and transfer of those weapons to then get them up to the flight deck. The Nimitz class was designed for that to happen on the mess decks. So they fold up all the tables, they move them to the side, and they move bombs on the mess decks on the Nimitz class. That's how they're designed. Then again, back to the day when cruise comfort wasn't, high on anybody's list in design. We've redesigned the entire weapons flow path from the bottom to the top. We no longer need to do any weapons movement on the main decks. We put in dedicated spaces for that elsewhere. So it's a real boost for the crew. It's good for their morale, it's good for their quality of life, and the most important part, it's a much more efficient way to move weapons, and they get from the magazines to the flight deck faster with the new design. So on the left of this, you'll see some berthing compartments. The berthing compartments are pretty standard as far as the kind of racks and the layouts, but there is an important difference. So if you're a sailor on a Nimitz class ship and you wake up in the morning and you want to take a shower, you got to put on a robe, you got to put on your flip-flops, you got to go out into the passageways, into the public spaces on the ship, and then transit to get to the showers and the toilets. They're not connected, right? So what we've done on this ship is each berthing space has attached to it its own dedicated shower and toilet facilities. So the crew, they can do all their personal things inside one dedicated berthing area. Hugely popular with the crew, right? Really fixes a problem, not a problem, but one of those parts of the Nimitz class that no sailor really loved. That's fixed. The other thing is because the showers, heads, and berthing are connected, you can change a berthing compartment from a male to a female or back with very little effort, right? There's no extensive modifications needed. You just change the label plate essentially, and you're ready to go. On the right-hand side are pictures of the captain's cabin. This was done a combination of the basic industrial work by the shipyard and then some donations from the Navy League and the Ford Foundation to finish up that space. And if any of you are familiar with carrier operations, the ship has a ceremonial role. They entertain dignitaries, entertain a lot of foreign dignitaries. And so this is the space where the United States entertains guests, where the commander of the ship can entertain people and represent the Navy in the country. And they did a really nice job. The space looks great. This is just more evidence of the completeness of the ship. The laundry, done, in use. You couldn't get this picture today because they're using it. The barber shop is up and running. Medical facilities are fully functional right now. So the crew is getting all their medical and dental care on board the ship right now today. and the crew's training. So we're going to go to sea later this summer. We're going to conduct builders trials. We're going to conduct acceptance trials, and then we'll deliver the ship in the early fall. So the crew's getting ready. They're doing all their firefighting training. They're doing casualty drills. That picture on the left is a drill, first aid drill. The crew on the right has a dummy Sea Sparrow missile that they're loading into the launcher. So they're getting ready to go. And so the whole point here is that other than finishing testing of a few key systems, the ship is not only ready, but in the crew's hands, and they're learning her as we speak. So I promised you I'd talk a little bit more about EMALS and AAG. So that orange sled is a dead load. It goes shooting off the front of the ship and skips across the James River until it comes to a stop, and then they grab a tug, comes around, grabs it, and they crane it back on board. So there's a variety of dead loads that have different weights. Those weights replicate the different aircraft in our inventory. And as I mentioned, we shot over 240 of those. The picture on the left is maybe the hottest day on the planet when Susan Ford Bales actually gave the command to launch a dead load. That's her in the bottom with her hands over her head. So we look at EMALS as a real success story here, given all the concern over it early in the ship's life and where we are now. She's really performing well. AAG is, you can't land a dead load on the ship. So most of the testing of that nature happens at Lakehurst. So the picture on the right is an F-18 rolling in at over 100 knots to an AAG arrestment at Lakehurst. Right now, to date, we've done a little less than 20, I think 13, with more coming. So there's two sites at Lakehurst. There's a site where they have a jet car powered by some jet engines, and they launch a dead load into the AAG wire. And then there's another site where you actually roll an aircraft in. And so that's what we have there. So this summer, we'll do many aircraft events with the wire and finish proving out the system land-based, while shipboard we finish construction and do the shipboard installation testing. So the Ford is the first of the Ford class. CVN 79 to John F. Kennedy is under construction at Newport News Shipbuilding right now. That's a picture of her in the dry dock as the units are being built and lowered into the dry dock. So I think you can see how it goes on the lower left. There's a pre-outfitted unit being lowered into place. They weld all those together, and they'll assemble several hundred of those into the Kennedy over the next several years. And you can see the Kennedy schedule there. They'll go through that whole erection sequence up until the launch in 2020. Now, I'm kind of jealous when I look at the Kennedy construction process right now, because we had to learn everything on the Ford. Everything was new on the Ford. I had got my material a little bit late. We had concurrent design and construction. We had a lot of learning. The CVN 79 has taken all of that learning and incorporated it. They've made many improvements, both in the shipyard and with the government system providers, and they're just going like gangbusters right now. Their cost performance is excellent, their schedule performance is excellent, and all the things that we paved the way for on CVN 78, they have turned those around into excellent lessons learned on 79, and so far it's doing a wonderful job. And finally, behind her will be CVN 80, which will be the Enterprise. And the Enterprise right now would go into an advanced procurement contract sometime later this year. So they're coming pretty fast. So to finish, we think that right now we're bringing some capability to the fleet that builds on the Navy's carrier legacy and propels us really well into the future from a capability standpoint, a flexibility standpoint, and a cost standpoint. And we're off to a great start on 7980 construction. And so, I would say we're in pretty good shape and ready to go. That is the conclusion of my prepared remarks.